So here in this problem, we need to determine the value of the given trigonometric expression. So let us begin. Now, we see here that the first term comprises of the product of two sine function, and also in the second term we have the product of two sine function. What we'll do first, we will try to convert the product to a sum of two trig functions by using a transformation formula that stated particular formula. So if we have the product of two sine function, then it transform as a difference of two cosine functions as shown here. So in our case, we don't have the factor 2 in each of the two terms, but that's fine. All we have to do is multiply and divide by 2. So we can rewrite the expression as half. We'll take half as the common factor. So this will be multiplied to 2 times sine of angle theta over 2 times sine of angle 7 theta over 2. So that's going to be the first term. That will be added to 2 times the second term. So that's sine 3 theta over 2 multiplied to sine 11 theta over 2. Fine. So let's try to apply this particular transformation formula. So we have half. Now in the first term, we have cosine of a minus b. So we'll consider a to be theta over 2 minus b to be 7 theta over 2 minus cosine of angle a plus b. So we have theta over 2 plus 7 theta over 2. Going to the next term, so we have cosine of angle a minus b. So we'll consider a to be 3 theta over 2 minus b, so that's 11 theta over 2 minus cosine of angle a plus b. So we have 3 theta over 2 plus 11 theta over 2. Okay, let's compute the value. We will get half multiplied to cosine of, so we have theta over 2 minus 7 theta over 2. So that's going to be negative 6 theta over 2 minus cosine of angle 8 theta over 2 plus cosine of angle, so 3 theta over 2 minus 11 theta over 2. So that's going to be negative 8 theta over 2 minus cosine of angle 14 theta over 2. Further simplification is going to give us, we have cosine of angle negative 6 theta over 2 is going to be negative 3 theta minus cosine of 4 theta plus cosine of negative 4 theta minus cosine of 7 theta. Fine. Now we know that our cosine is an even function. Even function means if we have cosine of negative theta, so that's the same as positive cosine theta. So that means we can now rewrite the first term as cosine of positive 3 theta minus cosine of 4 theta. Then we have plus cosine of 4 theta minus cosine of 7 theta. So we can cancel out the second and the third term, and we are now left with only two terms. So we have half multiplied to cosine of 3 theta minus cosine of 7 theta. So what we have is the difference of two cosine functions. So here we'll be using another transformation formula which converts the difference of cosine function to product of two trigonometric functions. So let's state that particular transformation formula here. So if we have the difference of the cosine function, cosine alpha minus cosine beta, it transforms into the product of two sine functions. So let us begin. So here we will get half multiplied to it will be negative 2 times sine of angle. So we need alpha plus beta. So we'll consider 3 theta to be alpha and 7 theta to be beta. So we have 3 theta plus 7 theta divided by 2 multiplied to sine of angle 3 theta minus 7 theta divided by 2. So that will be equals to negative 1 multiplied to sine. So we have 7 theta plus 3 theta. So that's 10 theta. 10 theta over 2 is 5 theta. Multiplied to sine of angle. So we have 3 theta minus 7 theta. So that's negative 4 theta divided by 2 will be negative 2 theta. Now sine is an odd function. So that will be negative sine 5 theta. So sine negative 2 theta will become negative sine 2 theta, using the fact that sine of negative theta, that's equals to negative sine theta. Sine is an odd function. So we finally get the product sine of 2 theta times sine 5 theta. So therefore, the value of sine theta over 2 times sine 7 theta over 2 plus sine 3 theta over 2 times sine 11 theta over 2, so that will be equals to the product of sine 2 theta and sine 5 theta.